We're going to do a short introduction this morning to our new armor truck scale. Our armor scale has been known for about 20-25 years as our ETR, standard steel deck truck scale. Pretty much standard of the industry, and it's been a real good design for us over the last couple of decades. But like anything else, there can be features made better and upgrades. Since truck scales were first developed back in the mid-1800s, they were actually wagon scales. A guy named Thaddeus Fairbanks devised the first in-ground scale to weigh vehicles on. They have been very labor-intensive as far as assembly, maintenance work, and keeping the scales up and running and accurate. It's just kind of the nature of the beast. In a typical truck scale suspension, really irrelevant of who the manufacturer is, there are multiple parts to assemble when you're putting a truck scale together. Very labor intensive. And because of that, there are numerous wear points. Over the years, pivots and bearings wear out, links wear out. There's just a lot of wear and tear. So there are just a lot of long-term maintenance issues on about any truck scale, irrelevant of manufacturer. This is pretty much what a typical truck scale suspension system looks like. You've got a corner stand with a bearing in it. You've got a pivot that sits on top of that, a double-ended beam load cell, a pair of suspension links with wear points, and then a load bar at the bottom. A lot of parts to assemble and a lot of parts to keep running correctly. So that's kind of an issue that's been out there for a long time. On newer electronic truck scales, there's a lot of complicated wiring. In a standard 70-foot truck scale, there are almost 100 electrical connections that have to be made correctly and terminated correctly for that scale to work. We've got up to 14 configuration jumpers that have to be set correctly for the scale to work. On a standard analog truck scale, we've got sense lines that are required to keep the excitation voltage correct, depending on how far the scale is from the digital indicator. It gets to be very hard to do sometimes. And with all of these things, any loose wire or a connection out of place and your scale doesn't work. That's a typical junction box there that's normally out in the truck scale that takes care of voltage suppression and lightning suppression. You can see looking at that, there's just a lot of wires crammed into that junction box that a technician has to make those connections when he installs the scale and every time he's working on it. Any error out there could be the problem with the load cell or the scale not running correctly. This is a typical trim junction box that's normally inside the office by the digital indicator. It has, again, surge suppression with diodes, with gas discharge tubes, potentiometers for calibration, just a lot of stuff that a technician has to deal with out there. And because of that, we get into issues sometimes. On a typical truck scale, for a one division change, let's say we're going from a reading of 0 to a reading of 20 pounds, the amount of voltage that it takes to make that change is less than 1/2 millionth of a volt. So anytime we get any moisture, even a little bit of dampness or high humidity inside that junction box, you can get some voltage leakage and all of a sudden the scale doesn't run correctly. It may drift and you may get inaccurate readings. Over the years, scale technicians, everybody keeps either a heat gun or a hair dryer in the cab of their test truck. Because the first thing you do if the scale's drifting, open up all the junction boxes and take a gun and try to get all the moisture out of it. That's just kind of a thing. Over the years, checking has been a big issue on truck scales. We have used bumper bolts, especially on old mechanical scales. We've used check rods. We've used stabilizers. People in the industry have used flexures over the years. A lot of maintenance there. When a truck drives on a truck scale, he weighs 80,000 pounds. If he's going 40, 50 miles an hour, he's going to destroy the thing. That's why a lot of times we'll put speed bumps in front of the truck scale. Try to slow him down to 4 or 5 miles an hour. But even pulling on at that speed, there's a tremendous amount of kinetic energy available in a truck that's rolling 80,000 pounds at 5 miles an hour. When he slams his brakes on, that energy has to go somewhere. We have to grab that. Check rods and things like that are just real high maintenance. This is about the worst example of a checking system that I could think of. There they have a bumper bolt that's attached to the actual base that the load cell sets on. So every time the weighbridge hits that bumper bolt, they're actually shocking the base of the load cell. And I wouldn't think that it'd stay in calibration very long like that. This is what a set of standard check rods looks like on a pit scale. And again, there's just a lot of maintenance there. You got to get down in the pit, adjust those. They'll get loose over time. High maintenance on them. We've got our signal low voltage is very, very susceptible to power surges and interference. It'll get you unstable weight readings there. Close proximity of the corner stands of the load cells to the concrete joint moisture, you'll have the corner stands rusting out over years, and the whole side of the scale will collapse. A lot of times the corner stands are just built out of like 8-inch channel iron that's only 3/16 of an inch thick, so they're susceptible to rusting out on. There's now a modern solution to age-old problems. We've been working for almost 4 years developing a new truck scale that's going to replace our original armor scales. It's called the new Armor with new SmartCell technology. Starting the first of the year, all of our standard truck scales are going to have digital load cells. The digital load cells let us do away completely with all of that wiring. All of the junction boxes are gone. The load cells will just daisy chain together with simple keyed connectors on protected cables. So all of that wiring nightmare is gone. We also do away with all of the checking problems that we've been fighting for the last 100 years on scales. There are no bumper bolts, there are no check rods, there are no flexures. There is absolutely zero maintenance on the checking system. This is what our new armor weighbridge looks like. It's an I-beam design with 12 I-beams. More important, we've increased the concentrated load capacity from 45 tons to 50 tons. We've got full-length I-beam structural members, so there are no joints anywhere inside from head to head on that weighbridge. There are no joints anywhere to fail. We've got the small no-bolt access covers. We've got the access covers completely out of the truck traffic path so they can't bend and cause problems. We've got bolt-on guardrails now, very heavy-duty load cell stands, ball suspension, and of course the SmartCell digital load cells that are the heart of the new system. This is what our new weighbridge looks like from down below. We've got 12 12-inch tall main beams equally spaced across the depth of the scale. What this lets us do, if a customer has a very special application, maybe he needs a little bit heavier duty scale, instead of a complete redesign, we can go like from a 12-inch, 12 pounds per foot up to 12.25. We can just put in a heavier sized I-beam without having to re-engineer the entire thing. This is our new access plate. You can tell there where the trucks are running, and the access plate's completely outside of the truck traffic path there. There are no bolts, it just drops in place. Usually you can just take a screwdriver and pop it right up out of there. This is a photograph of our new bolt-on side rails. The side rails on our armored truck scale for years have dropped down into a pocket on the scale. There weren't any bolts there. It was quick and easy to install them, but sometimes there would be an issue if a truck would come up and accidentally hit that guardrail real hard. Hopefully the guardrail would just bend to where it could be replaced. Sometimes that pocket that was welded on the outside of the scale would actually rip loose from the scale. So you'd have to go in and a welder would have to re-weld that and put it back on. With our new design, we're just using soft grade 2 bolts there, so that if the truck hits it hard, those bolts should just shear, kind of like a shear pin on a propeller on a boat. And any maintenance guy, it doesn't have to be a scale technician, a maintenance guy can just put it up there, throw a couple of bolts back in it, and you're up and running again. So hopefully, with those new heavy brackets on the side rails, the brackets won't bend and the scale won't be damaged, and you just throw a couple of bolts in it. This is our new corner stand. The thinnest piece of steel on our new corner stand is 1 inch thick. We should never have an issue with those rusting out, at least in our lifetime. Previous corner stands made out of channel iron, you're looking at material that was 3/16 or 1/4 of an inch thick, and over just a period of sometimes 8 or 10 years in bad environments, that corner stand would rust out and you'd have a failure on your scale. And our new corner stand is a minimum of 1 inch thick steel everywhere. Now, when the new armor with the digital load cell shipped from the factory, it comes to you fully assembled and fully calibrated. We assemble and calibrate every scale in the plant before it ships from here. Now, you can tell in this photograph they are getting ready to drill the mounting bolts, or the holes for the mounting bolts. Unlike our previous stands that had 2 bolts, these new stands have 4 bolts, and we are supplying the anchor bolts for them. Now, those anchor bolts have to be installed with an impact gun, either an air-operated impact or an electric impact. They basically thread into the concrete. So if you try to install them by hand, like with a ratchet, you'll end up just wearing the concrete out. So you have to have a gun so you can really lean on it, put some pressure in it, get it to catch the concrete and thread down in the concrete. But basically, after the stands are drilled, the 4 bolts are tightened, the shipping bracket that's there in the center of the load cell has 2 bolts. You remove those 2 bolts and throw that shipping bracket away, and the scale mechanical installation is pretty much done. This is what our new passive ball suspension looks like from down below. The corner stand has a hardened pocket sits there. It's basically like a saucer. The 2-inch diameter hardened ball sets in it, and then the bottom of the load cell has a radius built into it. Now, basically what happens when a truck comes onto the weighbridge and he applies his brakes, and that weighbridge has to absorb the energy of the truck, the ball will try to roll up that radius. And as soon as it starts rolling up the radius, it has to lift the weight of the weighbridge and the weight of the truck. So the heavier the truck is, the quicker it actually stops and comes back to rest. There's just a tremendous amount of force there that is required to lift that weighbridge up. And as soon as that ball starts rolling up the ramp, that tremendous force goes up and it comes back and rocks about twice, and you've got a stable weighbridge and get a good stable weight reading. Now, in that photograph, you can see between the weighbridge and the load cell, we've got a hardened bearing plate that sits there. If you would need to shim one of the load cells to get the dead load the same on initial installation, we ship shims where you can just loosen the bolt on the load cell. It doesn't have to be completely removed, and you slide a shim in there to bring your dead load readings up. This is our new double-ended beam digital SmartCell. Our new digital SmartCells are calibrated internally so that they are linear to their full capacity. Unlike an analog load cell, where basically the output of the cell is set at 2 millivolts per volt, and then you have to deal with whatever error curve is there. Internally, our new digital load cells, every 10,000 pounds, we drop a test weight on it, and then that load cell is calibrated every 10,000 pounds all the way to capacity. So it should be very, very linear. The cables that attach to the load cell, there is no in and out port, so you can't wire it wrong. The cables are keyed, where basically you line up a slot and a key and tighten that up good, and you've got a good weatherproof connection there. So there's absolutely no way that you can wire it incorrectly. This is the new Cardinal Armor concrete deck scale. It's got the I-beam construction. The great thing about our concrete deck scales, they don't require any secondary rebar. When our scales hit the job site, it takes about 2 hours to get the weighbridges set up, level them with the transit, put cribbing under the center of the bridge so it can't sag, and then you can start putting concrete in it and finishing it. Most of our competitors, it will take a day, day and a half, or 2 days to put all the extra rebar in the deck. It has to be tied together, just a tremendous amount of work. The Cardinal weighbridge requires no secondary rebar at all at the job site. Our new SmartCells pretty much are the heart of the armored truck scale system. You'll see later all of our digital calibration and the digital diagnostics that is just not available with an analog type load cell. The system components, we've got a 75,000 pound capacity double end SmartCell, waterproof connectors, and metal sheathed cable, where on our original armored truck scale, all of the load cell cables were ran in conduit. So if you had to change a load cell, first thing you had to do is take the cover off, get into the junction box, open up the junction box, disconnect the load cell cable, pull the cable through the conduit, change the load cell, pull the new cable back through the conduit, do all your connections, and it just took a long time to change a load cell. With the new design, it takes about 10 minutes to jack up the weighbridge, change the load cell, and get the scale back up and running again. We've got the simple ball suspension with easily replaceable hardened stand cups and suspension balls. The new suspension system is also going to be available in our SRC type pit scales that normally have double-ended beam load cells in them. In the field, the technician only has to terminate 5 wires in the indicator, and then there's a connector at the end of the home run cable he has to wire with 5 connections there, and that's pretty much all the wiring he has to do. Our standard Cardinal 225 indicator will run the system with an optional digital interface board and a special hex file that will be installed in the factory. This is a photograph of the hardened steel plate that's installed between the load cell and the weighbridge. And this is a hardened stand insert and suspension ball. The bottom of the insert has a radius on it so that if the stand is a little bit out of parallel, that the ball can actually, the insert can actually straighten itself up in the stand. Almost no parts, those are the only 2 parts that should ever be replaced in one of the new armored truck scales. And it would take basically 5 minutes to go in and put a new set of them in there. This is a photograph of our new braided load cell cables. They're waterproof and double O-ring. Should stand up to service for many, many years before one of those would have to be changed out. Normally, the cause of failure of a load cell cable is either abrasion because of the cable moving in the weighbridge, or rats, mice, rabbits, and squirrels chewing on cables. And with the new woven stainless steel cover on there, those kind of problems should be eliminated. This is the home run cable connector. This is one of the 2 places that the customer does have to make some connections. You've got to connect a pair of wires for 15 volts, plus and minus DC current to run the load cells. And then the other 2 wires, the signal wires, are just a CAN bus loop for CAN high, CAN low. And then there's a shield wire in the center. That connector has got double O-ring seals, and all you have to do at the scale. Those are the only 5 connections that have to be made at the scale. Now the system runs off of our new 225 DLC indicator. You'd order what would be the model number to be a 225D. It's a standard 225 indicator just with a special hex file, and you plug in the option card for the digital system. When we're first setting up the scale here at the factory, we have to tell the system the serial number of each load cell, because basically we get a digital output from all the cells and we're going to total them up. Sometimes in multi-platform applications, we may have to tell the system that the first scale has got 4 load cells, the second one 4, the last one may have 8, and the system needs to know those serial numbers so it adds up those weights correctly. Now all of the IDs are put in here at the plant. In the case of a load cell failure in the field, normally we can tell which load cell is bad. And when we see a new load cell that's been put into the system, we assume that new ID number was put in the slot where the old load cell was that was bad. So you don't have to do anything to add one load cell to the system. In the event that maybe you'd taken just a terrible lightning strike right to the deck and maybe 2 or 3 load cells went out, then you'll have to go in. If multiple load cells are changed, you'll have to go in and put those serial numbers in. Good thing is we've had a beta site running for almost 2.5 years now with 0 load cell failures. The state let us put it in before our NTEP work was even done on the weighbridge or the load cells. We got a special single site approval, and so we've had a beta site running for almost 2.5 years with no installation or calibration problems. Now, one thing that the customer has to do at the field, we don't know where he's going to run his home run cable to, and we really don't care. But the button, the third soft key to the right that says end nodes, what he's going to have to do is push the end nodes button, and the indicator is going to ask him which load cell connects to the 225. We don't care which one it is, just tell us which load cell you hook the indicator to. In this case, it's with the load cell number 1. You enter that, and then it says which load cell is the last in the loop. We don't really know if you're going to take the loop around the scale clockwise or counterclockwise, and again, we don't care. Just tell us where the end of the loop is. There's a end node connector you install there, and that way we can normally tell you when there's a break in the cable where that cable would have a problem at. And that's the only thing really at installation that the technician should do, tell us the first of the loop and the last of the loop. After that's set up, we go through normal setup and then calibration. The calibration of the scale here would be selection number 3. It's very similar to our ICANN system that we've had available for about 15 years. SmartCal is the normal way we're going to calibrate the system. With SmartCal, we would do a 0 calibration first, and then the system would prompt you to put a known calibrated weight over the odd load cells first, and then back down the even side of the cells. And at that point, the scale is basically calibrated. In some instances, if there's just been dead load added to the scale deck for whatever reason, you might want to do a 0 calibration and just recalibrate 0 and not recalibrate the span on all the load cells. A good point of that is the concrete deck that we had a photograph of there. That scale was calibrated here in the plant, but when we got it to the field and we poured the concrete in it, when we turned the system on, the system showed there was like 145,000 pounds setting on the scale. That was a dead load of the concrete we put in there. So we really didn't need to completely recalibrate the scale. We just needed to recalibrate 0. So we went in and did a 0 cal on it. Now, to make an adjustment to the output of a load cell or the output of a section, you would go to number 3 where it says trim cells. After you selected number 3, it would come up and say which load cell do you want to adjust. And you enter your load cell number. And like here, I've entered load cell number 1. I want to make a trim adjustment. The scale weight there is the actual live scale weight that would be normally displayed on the screen, so you can tell where you're at. The system here is a little bit different and a lot simpler to use from previous systems. Previously on the ICANN or on our SnapStream system, if you needed to raise the output of a load cell 40 pounds, you had to push the up key, sometimes multiple times to make that happen. And there's really no reason to do that. On the new SmartCell technology, if your test cart weighs 21,000 pounds and you want to adjust cell 1, you just park the test cart on cell 1, push the third button over that says set weight, you tell it you want that load cell to be reading 21,000 pounds, press enter, we do the math and automatically change that. So there's no more pressing up and down keys multiple times to try to get that weight adjusted. It makes it very, very easy to adjust the load cell. Now, if you want to adjust the section of the scale, you want to adjust 2 load cells at the same time, the same amount, you would just say, I want to adjust load cells 1 plus 2, and then press enter, and that will adjust both load cells on section 1 at the same amount. So it's very easy to make section adjustments. The real heart of the system and what really makes it easy for a technician, sometimes when you have a problem with an analog truck scale, it can take days to figure out where the issue is. There are so many wires, so many connections, You may be out there for a voltmeter with a voltmeter for hours trying to figure out what's going on. Our digital diagnostics does away with most of that. To get to the diagnostics, you'd press the red button in the middle of the arrow keys, and the cell diagnostics button comes up, and you'd push that second soft key there. This first screen shows the actual weight coming off of each load cell. Now, normally that's going to be just the weight of the weighbridge setting there. If you have a load cell and you would jack the weighbridge up at load cell number 1, that reading should go back down very close to 0, within the 0 balance tolerance. Now, the second diagnostic screen, if we have an issue with maybe a load cell that's got a drifting weight for whatever reason, a technician may get a phone call from the end user that says, hey, this scale's drifting all over the place, going nuts on us. On an analog system, sometimes that can take a long, long time to figure out what's going on. With this system, we come to the second screen, hit the 0 button, and then after about 10 minutes, you want to look at it. And if there's a load cell that's drifting 1,000 pounds, it may show the maximum of 1,000, the minimum still at 0, and you know, hey, that one load cell right there is moving around on us. There's an issue with it right there. So it's very quick and easy. Because we're getting digital signals, we can tell which load cell's moving around on us. This next screen is going to alert you to the problem with the output shift of a load cell. And normally if there's a problem with the dead load shift, there'll be an asterisk come up beside that load cell, and there'll actually be a number there, where these are all 0 because that scale had just been calibrated. Over years, you're going to see maybe a little bit of weight there as the 0 balance of the load cells change a little bit. You'll also see weight there if there's debris on the scale. If a truck's sitting on the scale, you're going to see a bunch of load cells with asterisks beside them. The diagnostics information should only be used when the scale doesn't have any weight on it, so that we know those are readings from the 0 of the load cell that we're getting. Here we've got a screen that is showing load cell communication errors. With our digital load cells, a technician can't use a voltmeter to test that load cell. All we get out of the load cell is basically X's and O's, high states, low states for a digital signal, and we know we're putting about 14 volts into it. There's not much a technician can do to troubleshoot that load cell. We have to be able to tell him when there's an issue. One of the issues you can have with a digital load cell is it's not communicating. When the 225 indicator requests data from the load cell, we should get data back immediately. If we don't get that data back, just like here, load cell number 1 says, I've had one time that I didn't get data when I requested it. Now, sometimes at startup, when you first turn the scale on, you may throw some communication errors because the load cells may not start immediately at the same instant that the indicator starts asking for data. So after initial startup, you want to 0 this screen because you may throw a few errors initially and there's really nothing wrong with the system. But after that point in time, historically, if there's a intermittent problem with the scale, the technician can come into the screen and go load cell number 1. You know, normally there might be hundreds of errors there. We're not getting good communication from there. So it makes it a lot easier for a technician to work with. The next error screen here is actually on the analog side of the A to D converter that's built into the digital load cell, where if there was an issue with the strain gauges or the circuitry, we would actually know that that A to D converter is not getting the correct amount of voltage to run, and we would show weight errors there. Normally, if you would show any large number of weight error counts, that load cell would have a problem and need to be replaced. When we get back out of diagnostics, if a technician's been working on the truck scale, maybe he's found some issues and he's got them straightened out, we always want to clear all of those error counters when we get out of there, so the next time the technician goes to look at it, if there are errors in the counters, that he knows those are problems that have came up since the last time he's been able to work on the system. But our new armored truck scale with new digital technology will probably be available right after the first of the year. We're real excited about it here at Cardinal, and should be a sales tool that's available for our people out there. We've made a real concerted effort to try to keep the pricing almost exactly the same as what our standard analog truck scale is. There's not going to be any big price add-on for the digital technology. It's going to be a sales tool for all of our marketing people and all of our dealers to go out and get more business for the company.